Welcome, everyone, to this new episode of our Student Spotlight series, where we are able to showcase some of the work our past students have done. I'm Charlotte, one of the outreach coordinators here at CCIR, and it's our pleasure today to have Ostap with us, who did one of our Future Scholars Program courses. So firstly, can you just introduce yourself? So tell us where you're from, what year you are in school, and then which course you took.
Hi, thank you for having me. So my name is Ostap. I'm 16 years old and I'm in 12th grade. I live and study in Canada. And here at CCIR, I took Future Scholar Program, and specifically it was astrophysics of compact objects like white dwarfs, neutron stars, and black holes. And my TA and professor was Dr. Alexander Mushtukov from University of Oxford.
And what interested you in taking that particular course?
Well, I was quite passionate about math in general, and I really liked physics, so I decided to combine these two particular fields into one, and that's how I found astrophysics, and that's led me to explore some of the programs here at CCIR. And when I found this particular program, I decided to try it and see if I like it.
And can you give the viewers an idea, just a general overview of what the course was about?
Yeah, sure. So the whole course was divided into two parts. During the first half of the program, you learn essence of astrophysics as a whole. You look at the fundamental concepts from physics and how these compact objects evolve, behave, what processes happen within them, and how they interact with each other. And what's really interesting for me is that you actually not only discuss those processes, but you also look at the math behind each concept to understand them better. And that was really interesting for me. And then in the second part of the course, you have an opportunity to either offer your own project or choose one of the projects that was offered by your professor. In my particular case, I found a few very interesting projects from the list of offered projects by my professor. And after some discussion with my professor, we added some additions to that project, and that's it.
And had you had any experience with astrophysics in school or before CCIR?
Not really. It's not like I had experience in school. I took a physics course, but it's not like specific branch of astrophysics. I had experience by reading some of the books and attending online lectures from universities, and that was all of my experience before CCIR with astrophysics.
Nice. So now we're going to shift to discussing your particular research project. So can you just tell us what maybe the title of your paper was, and then give a general overview of what you researched?
So the title of my research paper is 2.2 megaelectron-volt gamma-ray emission from accreting strongly magnetized neutron stars. It's quite long, but in essence, we'll look at neutron stars in binary system. It's kind of system where there are two stars, and we'll look at the processes of accretion that happen onto neutron star. And during the accretion, there is emission of certain types of lines. And in my research, we looked at how these lines interact with each other and evolve over time.
And what were your kind of research methods or your process of gathering and analyzing the data that you used?
So when I just started, my professor sent me a set of certain research papers from other scholars, and my research involved reading those papers, getting to understand the material of them, collect some equations to combine them, and analyze the data from those papers.
And can you walk us through the findings for your paper? Was there anything interesting or important that you found?
Yeah, there are actually a lot of interesting about this particular topic that I chose. First of all, some of the research papers that I was reading were over 2 decades old. It's because this particular topic is not very widely discussed due to lack of observational data of this line, but it is predicted that in near future this line should be detected, and those results that I got in my paper should have some influence on detection of this line, as we offer certain kinds of pulsars kinds of neutron stars that we should look for in order to detect this line.
And can you give us an idea of kind of maybe the importance of your findings to the field or to the general public and what that means?
Yeah, just as I said, it would be quite important. Detection of this line would give us more insights into the behavior of matter within neutron stars, how it behaves at very large densities, and some other processes within neutron stars, such as nuclear reactions at really large gravitational fields and magnetic fields.
And my last question about your particular research, can you tell us where you are in the publication process and how you've worked with CCIR to help you with the publishing?
So right now I adjusted the format of my research paper, and CCIR team haven't last look at it before sending it to the National High School Journal of Science. And what's really nice about CCIR program is that you always have support from the team and professor, and even after you finish the program, you have an opportunity to interact with CCIR team, and they would answer any questions that you might have with publication or sending it to conferences, and that's what I really appreciate about this program.
Great. So now we're going to shift to discussing just your general experience with CCIR and with the Future Scholars Program. So firstly, can you tell us what your experience was doing a program and a project like this is as a high school student?
It was quite unusual since I haven't had experience like that before in high school. So at first I wasn't sure if I will be able to do that, but then with support of my mentor and professor who guided through the essence of writing the paper, some key features that it should have, it was quite easy to go through it.
Great. And what was this research process like compared to other papers or projects that you've done in school before?
It was definitely more different than anything that I've done before because it was more in-depth research. You had to spend more time reading those papers, getting to understand what's it all about, and like analyzing data, more hard data to analyze. So it was more challenging than what I've done before.
And then, so for those watching, the Future Scholars Program is our group course. So can you just tell us what it was like working with other students? Do you remember where they were from and what that relationship was like?
Yeah, what's really nice about this program is that you work in small groups, so it's not a large group of people. So each of you have personal attention from the mentor and professor, and that's really nice that almost every person from that group is around the world. So there is a wide range of views and opinions on each topic and like concept. And what is really nice about my group is that two other people had a really similar topic for their research paper related to neutron stars, but they just explored a bit different processes happening within them. But in the end, if you combine all those results, all our three results into one, it would form a bigger picture, and that's what really nice too.
Great. And I think you mentioned one great aspect of our Future Scholars Program is that you're able to connect with students from all around the world, which is a really great benefit. And then can you tell us what it was like? So in both of our programs, we really like to emphasize the aspect of mentorship as opposed to the traditional teacher role, where our mentors are there to not really just transfer information onto you, but guide you through your own discoveries and learning process. So can you tell us what your experience was like with your mentor and your TA as you moved through the first teaching half of the course into the latter, more research-oriented half of the course, and how they helped guide you through that?
So yeah, just as you said, it's fundamentally, I think, different from what you get from teachers in schools, because here they don't just give you information, but they try to guide you through all of that information to give you hints and so that you can come up with those ideas by yourself. For example, in the beginning of the course, during the first half, my professor, he would give us set of problems and we would do them throughout the following week, and then on during TA sessions, we would just compare our results and to see if we got it correct. And then during writing process of the paper, of course, my professor, he guided through the essence of writing it, what each paragraph should have, and how to organize all the information concisely.
Great. And then just a few more questions. Firstly, do you think that this course has given you any insights into your future? Has it maybe informed or shaped how you think of your path moving forward, either in terms of your career or maybe just your choices in uni?
Oh, yes, definitely. When I just came to CCIR, it was one of my main points to see whether I would like to pursue further studies in this particular branch of astrophysics. And I think after finishing the program at CCIR, my opinion about this branch was solidified, and I will pursue further studies in this field.
Great. And then my last question for you, what would you say to someone who asked you what the value of doing a project or a program like this is, especially for a high school student?
Well, there are many benefits of doing such projects like that because, first of all, you have a chance to try if you would really like to pursue further studies in this field. And also, you have an opportunity to learn from people and their experiences who directly pursue their research in this particular field that you're interested in. So they can share some experiences, their experiences and knowledge that they had throughout all of their career in this field.
Great. So thank you so much again for chatting to me, and congratulations on your nomination to our Spotlight series.
Yeah, thank you for having me.